But for some reason, even though you learn so much about symmetry in quantum mechanics, which I assume most people have learned, with maybe one exception in this class, it doesn't help. I mean, it's really annoying. So if you go to our library, which I know nobody would ever do anymore, but if you actually dare to enter the book stacks, there are these things which are, not, they're digitized by Google, but they're actually physical objects. And you'll get to a section in math, which is, QC something, I forget what, QC 010, whatever it is, 10 0 point, blah, 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 the logical Library of Congress classification, which is called group theory. And suddenly you'll find out that there are like 3 whole stacks of books all called group theory. And you wonder why, because it's an obvious thing. So it turns out that it's not so obvious, and every time anybody understands some group theory, they write a book. And so the bookshelves are full of them, and they all look different because according to the application, the flavor changes of the group. So, it's different if you're doing D-branes from if you're doing, mercury spectral lines or whatever, or, some condensed matter thing. It has a different flavor every time. So the thing that unifies all these group theory books, almost all of them, is they're all linear. So this is now real embarrassment again. If I'm wrong, please bring that book to me and I will read it with great pleasure. As far as I can tell, all of them have to do with people learning something like quantum mechanics or some kind of physics, and they finally learned that you can do nuclear physics without doing some symmetries, and you write a book. But they're all linear, and this stuff is non-linear. So it'll turn out that the ideas that we have from group theory, again, one more time, need revision. I'm afraid there will be more books, and these books will be motivated by application in, let's say, fluid dynamics or something. And interesting enough, there's only a section like this in the library of symmetries motivated by fluid dynamics, but they only look at bifurcation of equilibrium. So they look at the epsilon neighborhood of a solution, which is linear. So they apply all the linear stuff to that. But turbulence doesn't care. Turbulence is not small perturbation of anything. It's a big, violent phenomenon. And epsilons are totally of no interest to turbulence. Thanks,